Welcome, friends, to the World Storie channel. I am your narrator, Ramis. Enjoy listening to the full story of artificial intelligence. Do not forget to write your opinion in the comments, and we will proceed. The idea of creating artificial beings has fascinated humanity for thousands of years. Long before the first computers appeared, people were imagining machines that could think, feel, and act like humans. The story of artificial intelligence is not only about technology, it is also a story about philosophy, culture, dreams, and fears. Myths and ancient dreams. Even in ancient myths, we find prototypes of artificial beings. In Greek mythology, there was Talos, a giant bronze automaton that guarded the island of Crete. He walked along the shore and protected the islanders from enemies. In Jewish folklore, there is the legend of the Golem, a creature made of clay that could be brought to life with magical formulas. In Chinese and Arabic manuscripts, we find descriptions of mechanical birds, musical automata, and mechanical servants. All of this shows that people have always dreamed of creating life with their own hands. Philosophers and the idea of the mind. In antiquity, philosophers asked themselves, what is thought? How does the mind work? Can it be represented as a set of rules? Aristotle created the first formal system of logic, rules of reasoning. This was the first step toward thinking of intelligence as something that could be formalized, and therefore, perhaps reproduced artificially. In the Middle Ages and Renaissance, thinkers like René Descartes wondered whether the human body was a kind of machine. The idea appeared that thought itself might follow certain mechanical laws. Babbage's analytical engine. In the 19th century, technology came close to reality. English mathematician Charles Babbage designed a machine he called the Analytical engine. It was never fully built in his lifetime, but the idea was revolutionary. The Analytical engine had a memory, an arithmetic unit, and the ability to perform conditional operations. In fact, it was the first project of a general-purpose computer. Babbage's contemporary, Ada Lovelace, realized that this machine could go beyond mere numbers. She suggested that the engine could process symbols and even create music. Ada is often called the world's first programmer. She wrote instructions for the analytical engine that we would today call an algorithm. Alan Turing and the idea of a thinking machine. The true foundations of artificial intelligence were laid in the 20th century. A key figure here is Alan Turing. Turing was a brilliant mathematician, logician, and codebreaker. During World War II, he helped crack the German Enigma code, which played a crucial role in the Allied victory. But Turing's most important contribution was his vision of the nature of thought. In 1936, he introduced the concept of the universal Turing machine, a theoretical device capable of performing any calculation that could be expressed as an algorithm. This became the foundation of modern computer science. After the war, Turing asked, "Can machines think?" To explore this question, he proposed what became known as the Turing test. The idea is simple. If a machine communicates with a human, and the person cannot tell whether it is a machine or a human, then the machine can be considered intelligent. This test is still discussed today, and it remains a benchmark in debates about AI. Turing also speculated about machines that could learn from experience. He suggested that instead of programming all knowledge at once, we could build a machine that learns like a child. In fact, this was a prophecy of what we now call machine learning. Tragically, Turing's life ended too soon. He was persecuted for his homosexuality, and in 1954, he died under tragic circumstances. But his legacy became one of the cornerstones of artificial intelligence. After World War II, computers began to spread across universities and research centers. At first, they were giant machines, filling entire rooms. But for the first time in history, humanity had machines capable of performing complex calculations. This was the moment when artificial intelligence began to emerge as a scientific field. At the Dartmouth Conference, Birth of AI. In the summer of 1956, a group of researchers gathered at Dartmouth College in the United States. Among them were John McCarthy, Marvin Minsky, Claude Shannon, and Nathaniel Rochester. They proposed to explore the idea that every aspect of learning or any other feature of intelligence can in principle be so precisely described that a machine can be made to simulate it. This meeting went down in history as the Dartmouth Conference. It was here that the very term artificial intelligence was coined. The first programs. The optimism of the early pioneers was enormous. They believed that within a few decades, machines would rival human intelligence. In 1955, Alan Newell and Herbert Simon created the program Logic Theorist. It could prove mathematical theorems from Russell and Whitehead's Principia Mathematica. This was a huge step. A machine could perform abstract reasoning. In 1957, Frank Rosenblatt invented the perceptron, a primitive neural network capable of recognizing simple images. Newspapers announced, "The perceptron will walk, talk, see, write, reproduce itself, and be conscious of its existence." The enthusiasm was intoxicating. Researchers believed that human-level intelligence was just around the corner. The early optimism and over-promises. In the 1960s, AI became a fashionable field. Marvin Minsky predicted that within a generation, the problem of creating artificial intelligence would be largely solved. In 1966, Joseph Weizenbaum created Eliza, one of the first chatbots. It imitated a psychotherapist by rephrasing user input. Many people felt like they were talking to a real person. This was the first example of humans emotionally connecting with a machine. But behind the excitement lurked difficulties. Early programs worked well in small, toy examples, but failed in real-world complexity. The first AI winter. By the early 1970s, governments and sponsors realized that progress was much slower than promised. The British government commissioned a report led by James Lighthill, which concluded that AI was unlikely to achieve its ambitious goals soon. Funding dried up. This period became known as the first AI winter, a time of reduced interest and money. The rise of expert systems. However, by the late 1970s and early 1980s, AI found a new path. Instead of trying to replicate all of human intelligence, researchers focused on creating expert systems, programs designed to solve specific tasks using the knowledge of human experts. One famous system was MySyn, created at Stanford. It helped doctors diagnose infectious diseases and suggest treatments. It was surprisingly effective and even outperformed some human specialists. Expert systems became popular in industry and business. Companies invested millions in creating systems for diagnostics, planning, and logistics. This was the second wave of AI enthusiasm. The second AI winter. But once again, expectations turned out to be too high. Expert systems were expensive to build and maintain. They required constant updating of rules, and often failed when faced with real-world uncertainty. By the late 1980s, interest waned again. Funding decreased. This became known as the second AI winter. Lessons learned. The two AI winters taught scientists a key lesson. Intelligence is far more complex than it seems. There are no quick solutions. Progress requires not only enthusiasm, but also new ideas, new mathematics, and powerful hardware. Yet, despite the setbacks, AI did not disappear. Small groups of researchers continued their work, and it was thanks to their persistence that the next revolution became possible. After the second AI winter, many believed the field would remain on the fringes of science. But the 1990s became a turning point. This was when a new approach emerged, what we now call machine learning. Machine learning, a new paradigm. The key idea was simple yet radical. Instead of manually coding knowledge and rules, why not feed algorithms with data and let them discover patterns on their own? This marked a shift from the old symbolic AI approach to statistical AI. Machines were no longer just collections of rules. They became systems that could learn from examples. Bayesian networks and probabilistic models. One powerful tool was the Bayesian network, a graphical model that calculates probabilities of different events. For example, if a person has a cough and a fever, what is the probability they have the flu? Probabilistic methods proved useful in medicine, economics, and engineering. Another breakthrough came from hidden Markov models, HMMs. They were ideal for analyzing sequences, such as spoken words. Thanks to HMMs, computers became much better at speech recognition. Support vector machines. In the 1990s, another powerful algorithm appeared, the support vector machine, SVM. It classifies data by finding the optimal boundary between categories. This method became hugely successful in tasks like recognizing handwriting, detecting spam, and distinguishing between cats and dogs in images. SVMs brought machine learning closer to practical applications. First real applications. During the 1990s, AI started to prove its value in everyday life. Speech recognition systems appeared in phones and call centers. Early translation systems, like the first versions of Google Translate, used statistical methods to convert text between languages. In medicine, algorithms helped analyze patient data and support diagnostics. It wasn't yet intelligence in the human sense, but it was undeniably useful. The revival of neural networks. Meanwhile, in the background, a small group of researchers kept working on neural networks, even though many considered them obsolete. Among them were Yann LeCun, Yoshua Bengio, and Geoffrey Hinton. They refined the backpropagation algorithm, which allowed multi-layered networks to be trained more effectively. Theoretically, it had been known since the 1980s, but only with faster computers, and later with GPUs, did it become practical to train deeper networks. For a long time, this work was ignored. But in the 2000s, it began to show its potential. ImageNet and the breakthrough. The real turning point came in 2012 with the ImageNet competition. ImageNet was a massive dataset containing millions of labeled images, organized into thousands of categories. That year, a team led by Geoffrey Hinton entered the contest with a deep neural network called AlexNet. It crushed the competition, reducing error rates by nearly half. The result was shocking. For the first time, a neural network showed a decisive and undeniable advantage over all other methods. The AI community realized deep learning was not just a curiosity. It was the future. On the new AI era, after ImageNet, a flood of research followed. Deep neural networks began to dominate in computer vision, speech recognition, natural language processing, and more. Tech giants, Google, Facebook, Microsoft, Amazon, Baidu, invested billions into AI. Startups emerged everywhere. Research labs exploded with new findings. Artificial intelligence had moved from a dream of academics to a real engine of technological progress. After the success of AlexNet and the ImageNet competition, it became clear. The era of deep learning had truly begun. But in the years that followed, a series of breakthroughs would completely redefine what machines could do. AlphaGo and the victory over humanity. One of the most symbolic milestones came in 2016. The company DeepMind, recently acquired by Google, unveiled its program AlphaGo. For decades, the game of Go was considered too complex for computers. The number of possible board positions exceeds the number of atoms in the universe. Brute force search was impossible. AlphaGo combined deep neural networks with reinforcement learning. First, it studied thousands of games played by humans. Then it began to play against itself, millions of times, refining its strategy and discovering moves no human had ever seen. In March 2016, AlphaGo faced one of the world's best players, Lee Sedol. Millions of people watched the match worldwide. In the fourth game, Sedol made the now legendary Move 78, hailed as a divine stroke of creativity, and managed to win one game. But AlphaGo ultimately triumphed with a score of 4.1. The world was stunned. For the first time, a machine had beaten a human champion in a game that symbolized strategic thinking and creativity. AlphaGo showed that AI was capable of finding solutions that surprised even the masters. Public Quasic Reinforcement Learning AlphaGo was a prime example of reinforcement learning. This approach mirrors how humans and animals learn, through rewards and punishments. An algorithm tries different actions, receives feedback in the form of rewards, and gradually learns which strategies work best. Reinforcement learning soon found applications beyond games. Training robots to walk, teaching drones to fly, optimizing energy systems, and even managing industrial processes. Transformers, a revolution in language. In 2017, a group of researchers from Google published a paper with a simple title, "Attention is all you need." It introduced a new neural architecture called the transformer. Before transformers, language models relied on recurrent neural networks, RNNs, which processed text word by word. But they struggled with long sequences and were computationally inefficient. Transformers changed everything. They introduced the attention mechanism, which allowed the model to consider entire sequences at once, capturing relationships between words no matter how far apart they were. This breakthrough became the foundation for modern natural language processing. With the rise of GPT and BERT based on transformers, two powerful families of models emerged. Google released BERT, which excelled at understanding context, revolutionizing tasks like search engines and question answering. Meanwhile, OpenAI developed the GPT series, Generative Pre-trained Transformers. These models were trained on massive amounts of text and could then generate fluent, coherent language. The release of GPT-3 in 2020 was a turning point. With 175 billion parameters, it stunned the world. GPT-3 could write essays, answer questions, generate computer code, and even compose poetry. Many people interacting with it felt for the first time that computers were speaking with something resembling creativity. In 2022, ChatGPT brought these models to the public. Suddenly, millions of people could interact with AI directly, asking questions, generating stories, drafting documents. It wasn't just researchers anymore. AI had entered the mainstream. Generative models and artificial creativity. Alongside language models, another revolution was underway. Generative AI for images, music, and art. Generative adversarial networks, GNs, introduced by Ian Goodfellow in 2014, allowed machines to create highly realistic images by having two neural networks compete against each other. Later, diffusion models emerged, capable of generating breathtakingly detailed images from random noise. With tools like DAL, Stable Diffusion, and Midjourney, anyone could type a text prompt and receive an original picture. Machines were no longer just analyzing data. They were creating art, music, video, design. AI became a new partner in the creative process. AI in science and medicine. At the same time, AI began making contributions to science itself. One of the most significant achievements came from DeepMind's AlphaFold project. For decades, biologists struggled with the protein folding problem, predicting how chains of amino acids fold into three-dimensional shapes. This is crucial for understanding life and developing new medicines. In 2020, AlphaFold stunned the scientific community by predicting protein structures with near-experimental accuracy. This achievement was hailed as one of the greatest breakthroughs in biology in decades. Suddenly, AI was not just a tool for engineers and technologists. It became a partner in fundamental science. A new reality. By the late 2010s and early 2020s, one thing was clear. Artificial intelligence was no longer an academic curiosity. It was everywhere. In phones, cars, hospitals, businesses, classrooms, and creative studios. But with its rise came new questions and new fears. By now, artificial intelligence was no longer a distant dream of scientists. It had entered daily life. We use it in our smartphones, cars, workplaces, and homes. We talk to chatbots, rely on recommendation systems, and generate images or text with a simple prompt. And of course, this has deeply influenced culture and society. AI in culture and fiction. The idea of intelligent machines has long fascinated artists, writers, and filmmakers. The science fiction author Isaac Asimov introduced his famous 3 laws of robotics in the mid-20th century. These laws became a cultural reference point for discussions about AI, emphasizing not only machine abilities, but also moral responsibility. Cinema, too, shaped how people imagine AI. In 2001, A Space Odyssey, the computer HAL 9000 displays intelligence, but also defies human control. In The Terminator, we see an image of hostile AI leading machines in a war against humanity. In The Matrix, humans live in a simulated reality created by AI, raising questions about freedom and perception. These works shaped the dual view of AI, a source of awe and creativity, but also a potential threat. Risks and challenges with power comes responsibility. Artificial intelligence opens enormous opportunities, but also brings risks. Bias in data. AI systems learn from the data they are given. If the data contains stereotypes or discrimination, the AI can reproduce and even amplify them. This can affect hiring, policing, lending, and many other areas. Fakes and disinformation. Generative models can create texts, voices, and images indistinguishable from the real thing. Deepfakes can be used for propaganda, fraud, or character assassination. Distinguishing truth from fabrication becomes harder. Impact on work. Automation threatens millions of jobs. Algorithms can write, analyze legal documents, design, and even code. At the same time, new professions emerge, centered on building, guiding, and auditing AI systems. Energy costs. Training giant models requires massive computing power, consuming enormous amounts of electricity. The environmental impact of large-scale AI development is becoming a pressing issue. Ethical debates. As AI becomes more powerful, questions of ethics intensify. Should machines have rights? Who is accountable for decisions made by AI? How do we protect humans from harm? Governments are starting to respond. The European Union is drafting the world's first comprehensive AI Act to regulate development and use. International discussions are underway, similar to treaties on nuclear weapons, to prevent dangerous misuse of AI. Researchers and companies are also establishing principles: transparency, fairness, responsibility, respect for human dignity. The question of the future: AGI and superintelligence. Today's systems are known as narrow AI. They excel at specific tasks, but lack general understanding. A model that translates languages can't drive a car or design a new drug. But many scientists dream of AGI, artificial general intelligence, a system with the versatility of human intelligence. And beyond that, some speculate about superintelligence, an intelligence surpassing humanity in every domain. Opinions are divided. Optimists believe AGI could emerge this century, perhaps even within a few decades. Skeptics argue that current methods won't get us there, and new principles are needed. Either way, the debate has moved from science fiction to scientific conferences.